Hey guys, welcome to the video for perpendicular lines. We are in Unit 4. Our essential question is, how can you tell if two linear equations are perpendicular? Okay, so we have already talked about parallel lines. And parallel lines are lines that have the same slope. They're parallel because they'll never intersect. If two lines have the same slope, they're never going to touch each other. So for example, if I have y equals 3x minus 5 and y equals 3x plus 2, these two lines have the same exact slope, a slope of 3. But they never intersect because their rate of change and their rise over run is the same constantly. So they're constantly rising 3 and going over 1, so their slopes, while they're exactly the same, they're never going to touch and they're never going to intersect. Perpendicular lines are kind of the opposite. They will intersect, but not just any type of intersection. So perpendicular lines are lines that intersect at 90 degrees. So if you wanted to draw an example of this, you would have to have two lines and they would have to be a right angle. So just because two lines cross, so for example, this is a not example or a non-example. Just because these two lines cross doesn't mean they're perpendicular. Perpendicular lines are lines that intersect at 90 degrees. Now, we're not going to be measuring the angles, but that's just the definition of perpendicular lines. So what makes two lines perpendicular? Well, we know that two lines that are parallel are because they have the same exact slope. So just like I showed you in Desmos, they had the same slope of 3. With perpendicular lines, they have to have opposite reciprocal slopes. I'm going to go ahead and explain what that means. Opposite means they have opposite signs. So if I have positive 3, what's the opposite of that? Negative 3. So opposite means you switch the sign. So if it's negative, you change it to positive. If it's positive, you change it to negative. Reciprocal means you flip the fraction. So if you were given the fraction 2 over 3, the reciprocal would be 3 over 2. You would flip it. So perpendicular slopes, you have opposite reciprocal. You have to change the sign and flip the fraction. So we're going to have some examples here on the side. The first example I'm going to use is 1 over 2. I want to do the opposite reciprocal of this. So if I wanted to create an equation that was perpendicular to the previous equation, if the original slope was 1/2, then the equation of the other line has to be the opposite reciprocal. Well, the opposite right here, this is a positive, so the opposite would be negative, and then I would flip the fraction, and it would be 2 over 1, right? But what's 2 over 1 the same thing as? 2. So I would have 1/2, the opposite reciprocal would be negative 2, and vice versa. Negative 2, the opposite reciprocal is positive 1/2. Another example, let's say negative 4 over 5. Well, this is currently negative, so opposite would be positive 5 over 4. So you have an opposite sign and you flip the fraction. Okay, next example. Let's say we have positive 3. Okay, we have positive 3. So I know the opposite would be negative, and we want to flip 3. Well, to write 3 as a fraction, it would be 3 over 1. So if we flipped it, it would be 1 over 3. So 3, the opposite reciprocal, would be negative 1/3. That's the hardest part about perpendicular lines. Unit 4 is challenging because we just don't read very well. So if the problem asks for you to create a parallel line, you want to use the same slope. But if it asks for a perpendicular line, then you have to treat it like perpendicular slopes. You do not want the same slope. Okay, so now we're going to go ahead and jump into just identifying and see if we can tell if two lines are perpendicular. So starting with number 1, we have y equals 3x minus 5 and y equals negative 3x plus 2. Can we tell what the slope is of a line just by looking at it? Sometimes. In order for us to know what the slope is, we want it to be in slope-intercept form. Y equals mx plus b. When it's in this form, it's easy for me to identify what the slope is because it's always attached to my x variable. If it's not in slope-intercept form, we need to get y by itself. So in number 1, both of my equations have y by itself. They're both in slope-intercept form. the slope of my first equation is positive 3. We're identifying the slope because we're trying to determine whether these are perpendicular or not. The slope in my second equation is negative 3. Are these opposite reciprocals? No. They're not parallel because they're not exactly the same, but what do we notice here? If I wanted the opposite reciprocal of positive 3, I would need negative 1 over 3, right? If I wanted the opposite reciprocal of negative 3, I need positive 1/3. So these are not perpendicular. And I'll show you in Desmos. These are not perpendicular. So the short answer to this would be no, they're not perpendicular. Just say no. So I have y equals 3x minus 5 and y equals negative 3x plus 2. Okay? Now, yes, these two lines intersect each other. And if you're wondering where these equations came from, they came from problem number 1 in our notes. The two lines do cross each other, but they don't cross each other at 90 degrees. And that's the big key here. So if we have perpendicular lines, they should cross at 90 degrees. But again, we're not going to be measuring that. Okay, let's identify the slope of the first equation. Well, can I identify it from the way it is? Yes, because it's already in slope-intercept form. Y is by itself. Our slope in the first equation is negative 2. What is the slope in the second equation? Positive 1/2. Are these opposite reciprocal slopes? Well, if I have negative 2, the opposite reciprocal would be positive 1 over 2. So I do have opposite reciprocals here, so yes. Right? We have negative 2. If we want to change it, it would be positive 1/2, and that's what we have here. Okay, moving on to 3. Do I know the slope of my first line by just looking at it? Yes, because y is by itself, so we have y equals mx plus b. Now, what number is attached to x here? Negative 5. So our slope for the first equation is negative 5. What's the slope for the second equation? Positive 5. Are these opposite reciprocal slopes? No. Are they the same slope? No. They have to be exactly the same to be parallel, and they have to be opposite reciprocal to be perpendicular. Here, they're just opposite. They're not reciprocal. Opposite means you have different signs. Reciprocal means you should have a fraction or something in the other one where you flipped it already, and this doesn't. So, is this perpendicular? No. If I wanted perpendicular with this one, I would need positive 1 over 5, and if I wanted perpendicular with this one, I would need negative 1 over 5. So I don't have either of that, so these slopes and these equations are not perpendicular to each other. Number 4. Do I know the slope of the first equation? Yes, because y is by itself, so it's in y equals mx plus b. The slope here is positive 2 over 3. Do I know the slope of the second equation? If you said 3, you made a mistake, because y is not by itself. We need to get y by itself in order to determine what the slope is for this equation. The first thing I would do is subtract 3x on both sides to get y by itself. 2y equals 6 minus 3x. But y is not by itself yet, so we need to keep going. We're going to divide all of our terms by 2. Y equals 6 divided by 2 is 3. Negative 3 divided by 2 is negative 3 over 2x. So what is my slope in this one? Negative 3 over 2. Are these opposite reciprocal slopes? Positive 2 over 3 and negative 3 over 2. Yes, so they are perpendicular to each other. And let me go ahead and graph these equations. So I'm going to graph y equals 2/3 x plus 1. Okay, so I've graphed that. The other equation was 3x plus 2y equals 6. These cross at a 90-degree angle. They're perpendicular to each other. They have opposite reciprocal slopes. So again, opposite means different signs. Reciprocal means you flip the fraction. Okay, starting with number 1. Write an equation of the line that goes through negative 2, 3 and is perpendicular to y equals 1/2 x minus 1 in slope-intercept form. Okay, so here we're given a point and we're given a line. So we need to create a perpendicular line. How do I know perpendicular? Because it says perpendicular. The hard part about this unit is that we don't read. The most common mistake is that everyone treats everything like a parallel line, but they ask specifically for a perpendicular line, so you cannot treat it like a parallel. Perpendicular means I'm going to have opposite reciprocal slopes. Okay? Well, do they give me a specific point that the new equation has to go through? Yes, -2, 3. They gave me that point. Now, they gave me a line as well. They gave me the equation of a line. If I wanted to make a parallel line, I would use the same slope that it has. Before I start, I need to look and see, do I know the slope in this form? Yes, y is by itself. I have y equals mx plus b. So what is the slope of this line? The slope of this line is 1/2. Okay, that's the slope of this equation. Do I want to use this slope to make this new equation? No, because we want to make a perpendicular line. If I wanted to make a parallel line, I would use 1/2. But because I want to make a perpendicular line, I need to change my slope. So my new slope is going to be -2/1, or just -2. Okay, because -2/1 is the same thing. So I don't even care about my old slope anymore. I only care about the new one. So I have my new slope and my point, and that's what I'm going to use in my point slope form. Y minus 3 equals -2x plus 2. Okay, I'm using my point and my slope. Now, it wants it in what form? Slope-intercept form. So I want to make sure that I'm giving it in slope-intercept form. I don't want to accidentally leave it in point slope form because I didn't read, right? So to begin point slope form, or slope-intercept form, we want to distribute first. Y minus 3 equals -2x minus 4. And then we want to get y by itself, so plus 3 on both sides. And you can only add to like terms. Y equals -2x minus 1. This is my new equation. I wrote an equation that is perpendicular to the other equation, and it goes through the point -2, 3. So I'm going to go ahead and graph this. They gave us an equation. Y equals 1/2 x plus, is it plus? Minus 1. This is the equation they gave me. Then I have to make sure that the new equation goes to the point -2, 3. So let's go ahead and plot that. -2, 3. Whoops. Okay. So they gave me the equation y equals 1/2 x minus 1. That's the equation that I started with. Then they gave me a point in blue. And they're saying, hey, I want you to create an equation that goes through this blue point and is perpendicular to the red line. So we created an equation. We used our different slope and we used our point and we put it in point slope form and got y equals -2x minus 1. So let's see what happens if we graph this. Y equals -2x minus 1. And I'll change this to be blue because it matches our notes. So, okay, so we're given the red line at the very beginning. That's the equation that we start with. Then they give us a green point and they say, hey, make a perpendicular line. Make sure it goes through this green point. And so we did. We got y equals -2x minus 1. It goes through the green point and it is perpendicular to the red original line. That's what we're doing here if you're thinking about it graphically. Okay, moving on to number 2. We're going to do the same thing. We're going to write an equation of a line that goes through -3, 2 and is perpendicular. Remember what that means. It means it has opposite reciprocal slopes to the line x minus 3y equals 7 in slope-intercept form. Now, they gave me a specific point that they wanted to go through. They wanted to go through -3, 2. But do I know what slope I needed to use that? No, right? Am I able to determine the slope of this line just by looking at it? No, it's in standard form. I needed to have y by itself, so that's y equals mx plus b. So this is my equation. The first thing I'm going to do is I'm going to subtract x on both sides. Not y equals, -3y equals 7 minus x. And then I'm going to divide everything by -3 to get y by itself. Negative 3 divided by negative 3 cancels. Whoops, I meant to pick red. Y equals negative 7 over 3. And then what's the number in front of x? Negative 1. So then I have negative 1 divided by negative 3, which is positive 1/3 x. Okay, now what's the only thing that I've done here? Really, the only thing I did was convert this equation in a slope-intercept form. That's really the only thing I did here, but that's not where I want to stop. Sometimes students stop here and they're like, oh, this is my answer. That's not your answer. You haven't done much. All you've done is convert an equation, and it's not even the equation that you need to write. So why did I even do that? Well, I want to know what the slope is. That's why I did all of this. So when I'm looking at this, I want to say, hey, what's the slope here? The slope here is 1/3. Is this the slope I want to use for my equation? No, because I need a perpendicular line. Perpendicular lines have opposite reciprocal slopes. If I were to use this slope, I'm making a parallel line, right? We want to use opposite reciprocal. So our new slope, well, if I had 1/3, my new slope is going to be negative 3 over 1, or just negative 3. This is the new slope I want to use. So then I'm going to start in point slope form. Y minus 2 equals negative 3x plus 3. Okay, so I'm using the point and I'm using the slope. Now what form do I want this in? Slope-intercept form. So the first thing I'm going to do is I'm going to distribute. Negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. And then the next step is I'm going to add 2 to both sides. Y equals negative 3x minus 7. Okay, I've created a perpendicular line to the original equation. This was the original equation. I've created a perpendicular line to it. Okay, moving on. Number 3, write an equation of the line that goes through 4, 5 and is perpendicular to 3x plus 2y equals 10 in slope-intercept form. Okay. We know we want it to be perpendicular, right? We know that because it says that there. If it wanted parallel, it would have said parallel. So make sure you don't treat it like a parallel line. Did they give us a point that the equation needs to go through? Yes. It wants us to create an equation that goes through the point 4, 5. So, for example, let's graph this in Desmos. We have the point 4, 5. We'll label it green, just like in our notes here. Then they gave us an equation, 3x plus 2y equals 10. Okay, so they gave us an equation, which is graphed in black. But let's go ahead and change that color. Let's make it red. So we have the red original line, and then it gives us a green point. It says, hey, you need to make a perpendicular line to this green point. It needs to cross the red line. Okay, so that's what we're going to do. But do we know the slope that we need to use just based off of what we have here? No, right? We need to get this by itself, or we need to get the y by itself so that we have slope-intercept form. So the first thing I'm going to do is subtract 3x on both sides. 2y equals 10 minus 3x. Well, y is still not by itself, so we got to divide everything by 2. So we have y equals 5 negative 3 over 2x. What is the slope of this equation? Well, I know what the slope is because y is now by itself. That's why I have to convert. So my slope is negative 3 over 2. Is this the slope I want to use? No, I want to create a perpendicular line. If I wanted to create parallel, I would use negative 3 over 2. But because I want to make perpendicular, I have a new slope. I use something different. I'm going to use the opposite reciprocal. So since I have negative 3 over 2, the opposite reciprocal will be positive 2 over 3. This is my new slope. So now I'm going to start in point slope form again. Y minus 5 equals 2/3 x minus 4. And then I want it in slope-intercept form. So we're going to go ahead and distribute. 2/3 times x is 2/3 x. 2/3 times negative 4 is going to be, I think that's negative. Did I mess up? Give me 1 second. Okay, So this would be negative 8 over 3. And then I still want to add 5 to both sides. Y equals 2/3 x. And then negative 8 over 3 plus 5 is, as a fraction, positive 7 over 3. All right, I'm going to double check my math real quick. So we had a point, and then we had an equation. So we subtracted 3x first. 2y equals 10 minus 3x, divided everything by 2. Okay, so I was just making sure because I just for some reason remember this problem differently. This is my equation. So let's check to see if it goes through that green point. We're going to type this in Desmos. Y equals 2/3 x, and we're going to go ahead and change this to blue to match our work in our notes, plus 7 over 3. It goes through the green point, right? Our blue line goes through the green point, and it's parallel or perpendicular to the red line. So I know I did that good, or did that well. All right, so again, the only difference between this and parallel is that you're not using the same slope anymore. With parallel lines, oops, I already erased everything, but with parallel lines, you want the same slope, okay? But with perpendicular, you want opposite reciprocal slopes. All right, let's start with the next section, and these are usually pretty simple, but they're also easy to forget also. So they're easy, but easy to forget. We want to write an equation that is perpendicular, so that means we want it to cross, right? We want it to cross each other. We want lines that cross to the x-axis. Oops. We want it perpendicular to the x-axis. And it goes to the point 3, negative 1. On these, it's helpful to draw a picture. Why? Well, they didn't give us an equation to work with. They give us, and they tell us we want it perpendicular to the x-axis. When I see keywords like this, I want to know, hey, it's easy to draw a picture because I can visualize that better. Because you're like, where's the x-axis again? So if you see x-axis or y-axis or anything like that, draw a picture. It really helps. So I'm going to go ahead and draw some tick marks. All right, and we're going to plot the point 3, negative 1. That's going to go right there. Now, I want this perpendicular to the y-axis, or to the x-axis. The x-axis is right here. I'm going to highlight it in yellow. I want it perpendicular to this. So, do I want it to cross the x-axis or be parallel and never cross? I want it to cross. I want it to be perpendicular. I want it to go through this point but be perpendicular to the x-axis. So, it's going to look something like this, right? Because now I have the x-axis and then my line. Those are perpendicular. What happens if we have a horizontal line? Well, if you draw a line that looks like this, that's parallel to the x-axis. It's never going to intersect. We want perpendicular. So the equation of this line, well, if it's a vertical or a horizontal line, it's either x equals or y equals. And the way you know is what axis it crosses through. So my purple line crosses the x-axis. So I have x equals, it crosses at the point positive 3. Okay? Number 2, write an equation perpendicular to the x-axis and goes to the point negative 2, 4. Again, I see the word perpendicular, which means I know it has to cross something. So, and it says the x-axis, which helps me by saying, oh, let me go ahead and draw a picture so I can visualize this a little bit better. Now, don't forget that you're not being asked to graph. You're doing this to help yourself. The key thing in here is being able to write the equation. So if all you do is graph, you haven't really answered the question. All right, we want it to go through negative 2, 4. So we're going to graph negative 2, positive 4. And we want it perpendicular to the x-axis. So I'm going to highlight my x-axis so we know what we're looking at. I want it perpendicular to that. So would I want a horizontal line? No, because that's going to be parallel to the x-axis. I want perpendicular, so it's going to go straight through. So because it goes through the x-axis, it's going to be x equals, and then the number that it goes through is negative 2. All right, moving on. Number 3, write an equation that is perpendicular to the y-axis and goes through 4, negative 2. So we're going to go ahead and draw our graph again. Because it says y-axis, so it's like, okay, let me visualize this so I can see it a little bit better. I want it perpendicular, right? So we want to make sure that we do that. And we want it perpendicular to the y-axis. So let's plot our point 4, -2. Oops, that's 5, -2. 4, -2, perpendicular to the x-axis. Perpendicular. That means we want it to cross, or the y-axis, I'm so sorry, I keep reading it wrong. Perpendicular to the y-axis. So I highlighted my y-axis already, right? I want it to be perpendicular to that. So would I want a horizontal line, or would I want a not a horizontal line. It's been a long day. Would I want a vertical line, or would I want a horizontal line? Well, I want it to be perpendicular, so I want it to cross. So I need it to be a horizontal line. Vertical line means it would go straight up and down, and it would be parallel to the y-axis. So this line goes through the y-axis, so it's going to be y equals, and it goes through the point -2. All right, and then the last one, write an equation that is perpendicular to the y-axis, and it goes through the point -3, 2. So let's go ahead and draw our graph here to help us visualize. -3, 2 is going to be here. Perpendicular to the y-axis. So let's highlight the y-axis so we know what we're looking at. If we want it perpendicular, we want it to cross the y-axis. So it's going to go horizontally. It goes through the y-axis, so it's going to be y equals, and it goes to the point +2. So again, these are super easy, but super easy to miss as well. If you have any questions, please feel free to come in for tutoring. The most important thing about perpendicular lines is that you have opposite reciprocal slopes when you're writing the equations. That's the important part here. And then sometimes you're just asked to say, hey, are these perpendicular or not? And all you have to do is to find the slopes and compare them. And once you've compared them and you've determined your decision, that's how you know. You're not asked to come up with the perpendicular slope. You're asked to determine whether it's perpendicular or not. Okay? If you have any questions, please feel free to come in for tutoring.